another index which are talking about the zero index and the negative indices. So look at the zero index and the negative indices. The zero index and negative indices. So at first we are on the other side, we are dealing with the positive ones. Now we are looking at a scenario where you have the zero index or the negative indices. How do we handle that? Not so. So we are going to say if n is less than m, what does it imply? This is the same as if you happen to bring this one is the same as n minus m is less than 0. And if n equals m and n equals m, this implies that n minus n, where there is m, you can put m. Where there is m, you just put m. If I've said that if n equals m, which is equal to 0. We want to look at those scenarios such that we move on. So we can write this as, we are starting with Roman 1. A power 0. A power 0, and start with a power 0. A power 0 is the same as what? That's what we want to find is the same as, how can a 0 come in? It came in when you said n minus n equals what? 0. So this is the same as a power n minus n. Because n minus n, you get a 0, which is the same as a power 0, which is the same as 1, So whenever you see that, how did it come out? That's what we want to know. Before knowing that is equal to 1, we want to move on to this. Follow the other idea. When we are subtracting, when we are dividing, we are subtracting. So it is the same as a power n all over a power n. Because when you are dividing, we subtract the powers. So this divided by this, you come out with 1. So where you see that a power 0, any number power 0 is the same as 1. Where did it come from? It came purposely from the rules of what? Indices. Roman 2, a power negative n. Where could it have come from? It is the same as a power 0 minus n. Because when you say 0 minus n, you are going to get a negative n. So the same story applies. This is the same as a power 0 divided by a power negative n, which is divided by a power n, which is the same as a power 0 out of a power n. So we say the a power 0 is the same as 1 out of a power n. So therefore a power negative n is the same as 1 out of a power n. So when a number is raised to a negative power, it's the same as 1 out of a number having a positive power. So that's what we want you to know. So that's where the first those index came from. Some people have been claiming that any number power 0 is 1, but where did it come from? So that's what I wanted you to be in your mind to know that that one doesn't happen like that. Equally, when it goes to Roman 3, a power negative n. We have already said it is already 1 out of a power n. And if I have a power n is the same as 1 out of a power negative n. That's one I want you to know it very, very well. So Roman 4 is a out of b power negative n. When you have a power which is negative, you take the reciprocal. This is the same as b out of a power positive n. If you have b out of a power negative, you just take the reciprocal of that. Where, on this scenario, where b is not equal to 0, why we emphasize that b is not equal to 0? If b is equal to 0, everything will become meaningless. Yes, and may become infinite. Take an example. A divided by 0, that means everything will be 0, it will be nothing. And if you say 0 divided by A, it will become infinite, because 1 divided by any number divided by 0, it can't happen. It becomes meaningless. So that's what I wanted us first here on that. That's what happens to zero index. So as still on that, we are going to look at what we call rational indices. And look at also rational indices. And whatever we are developing here is going to be implemented in the whole mathematics. So we are going to look at rational indices. We are going to look at what we call rational indices. So when we talk about rational numbers, we mean the numbers which have no exact square root. Like an example, root 3, square root of n. Any number which has no exact square root, which you know, those ones we call them their rational indices. You can say also rational indices follow the usual basic. You can even write that one also rational indices follow the usual laws of indices. So the same, even if we are multiplying numbers of the same base, we do addition. If we are dividing, we do the subtraction. So that's what we wanted you to know, is that. However, in this case, a must be greater than 0. So, and a must be strictly a positive. So in this case, a must be greater than 0, and a is strictly positive. And a is strictly positive. So here we don't deal with a being a negative. A must be a positive. Must be a positive. That's what we normally do that. So you can say, thus provided that a is greater than 0, provided that a is greater than 0, and n is a positive integer, and n is a positive integer, provided a is greater than 0, and n is a positive integer, and n is a positive integer, and n is a positive integer, the term a power 1 over n, the term power 1 over n is taken to be the positive nth square root of a. I.e., if you say a power 1 over n is the same as the square root of n of a. So when you say a power 1 over n is the same as square root of that number. For example, if somebody turns 4 power half, what is he meaning? He's meaning square root of 4. If somebody writes 8 power a third, is the same as the cube root of 8. If somebody writes 5 power a quarter, is meaning the fourth root of 5. Like that. So those ones we call them the rational indices. And as I have said, they still follow the same rules. They follow the same rules of indices. If we are multiplying numbers of the same base, still we do the addition. If we are multiplying, we add. If we are subtracting, we divide. If we are dividing, we subtract the same way. So that's what we are trying to talk about, rational indices. I can even give you an example related to that before we go into the cases which have been planned for you today. Always follow them and the introduction in the whole of mathematics. What we are going to be using, we shall be buying these rules of indices. So I can start by giving you, for example, move on. I want to encourage you that follow these rules. When we go on, we are going to be using them in these examples which we are going to do in all.